At Brownells, we enjoy helping shooters who are just getting into reloading. This video series will give you an introduction so you can see how easy and enjoyable it can be, besides saving you some money. So let's look at several reasons why people choose to reload. Shooters load for economy. Economy has always been one of the justifications for reloaders. When reloading, you can save up to half the cost of buying factory ammunition, which means twice as much shooting. Shooters load to achieve better accuracy. By fine-tuning your hand loads, you can develop custom ammunition tailored for your particular firearm that shoots better than the one-size-fits-all factory loads. Shooters load to have a variety of choices with respect to bullets and velocities. No ammunition manufacturer can begin to produce all the combinations of styles, weights, and brands of bullets, along with all the different powders. When you reload, you are in charge and get to choose the recipe you want to use. Reloaders can produce their own hand loads as needed. They don't have to worry about the supply of ammunition. And they can also reload obsolete cartridges that are no longer loaded by any of the ammunition manufacturers. As long as you have the correct brass, powder, primers, and bullets, you can produce 20 rounds to get your antique rifle shooting again, or 100 rounds for a fun day at the range. And finally, personal satisfaction. It's a whole lot of fun. The personal satisfaction of shooting a great score in a match or taking down a prize whitetail is definitely enhanced by developing a good load for your firearm and personally handcrafting each round you use. Reloading is a very safe and enjoyable hobby. By following the basic steps, you can reload your own ammunition with confidence. Let's go over some safety rules for reloading. Number 1, store your reloading supplies in a safe place away from children and any source of possible ignition. This includes keeping your primers and powders separate and following the recommended storage methods, usually in a cool and dry place. Number 2, use reloading manuals, especially for new cartridges. Start low with powder charges and work your way up slowly while watching for warning signs of pressure or case fatigue. Refer to these manuals frequently and keep them updated. Number 3, locate your reloading activity where you will not be distracted. If you get interrupted, stop and restart only when your mind is back on the task at hand. Distractions, like watching television or talking with someone, will eventually lead to mistakes. Number 4, do not mix powders. Keep them clearly marked and dated. Number 5, if you reload the same cartridge for different firearms, be sure your loads headspace properly in each firearm. Learn and understand the implications of headspace. We'll discuss this further later in the series. Number 6, check cases frequently. Look for split necks, case head separation, or other signs of fatigue. Finally, number 7, if reloading military brass, be aware that case capacity is usually reduced and initial load should be at least 10 to 15% lower than published data. Let's briefly review the 4 components that make up any metallic rifle or pistol cartridge. The 4 basic components are the case or brass, the primer, the powder, and the bullet. The foundation of any ammunition is the cartridge case or brass. We sell a wide variety of new brass from various manufacturers, or you can use brass left from your factory ammunition. If you're a first-time reloader, we recommend you start by purchasing a bag of 100 cases. Now let's look at the various parts that make up a cartridge case. At the top of the case is the mouth. Just below the mouth on a bottleneck cartridge is the shoulder and neck. This will be omitted on a straight-walled case. Next, the walls or body, which are the main portion of the case. At the bottom of the case, we see the head of the cartridge, which includes the extractor groove. Inside, at approximately the same point, is the web of the case, which gives the case much of its strength. Also located at the case head is the primer pocket, where the primer is seated. Primer is the ignition source for the powder and consists of a small brass cup with an anvil and filled with explosive compound that is ignited when struck by the firing pin. The flash hole passes through the case web and vents the primer flame into the powder chamber to ignite the charge. Most modern rifle and pistol cases are designed for boxer-style primers. Primers are available in 1,000 count boxes or 100 count sleeves and usually only represent 2 to 3 cents of the cost of a loaded round. They need to be kept in their original container and locked up from curious children. Powder is our next component. The 3 common forms of modern smokeless powders are flake, ball, and extruded. By altering the shape and size of the granules, manufacturers effectively change the burn characteristics. For example, rifles require a slower burning powder, designed to complete the burn down the longer barrel to achieve maximum velocity, while pistols require a faster burning powder to effectively complete the burn in a shorter barrel. Please note that most modern cartridges use smokeless powder, not black powder. The two are not interchangeable. Always use your reloading manual's recommended powder for the specific cartridge you are reloading. The last component is the bullet. The majority of bullets can be divided into 3 differentiating factors: tip shape, ogive, and heel shape. The first and most common tip is the full metal jacket. This is a no-frills tip, making it the most cost-effective and a favorite among plinkers. Next is the hollow point. It's used by hunters for its expansion, which limits the depth of penetration into the game and causes more extensive tissue damage. Hollow points are also paired with polymer tips to achieve a more aerodynamic shape, giving them a higher ballistic coefficient. Finally, the soft point. Like the hollow point, its primary use is hunting, but it's designed to pierce the tough hides and muscle of larger game that require deeper penetration. Now let's talk about the varying types of ogive. The term ogive refers to the curve of the bullet's forward section. The first and most common of rifle rounds is the Spitzer. A Spitzer bullet is used to achieve a higher ballistic coefficient. This enables it to retain more velocity and energy at long ranges and gives it a flatter trajectory. Spitzer bullets are an excellent choice when shooting at ranges in excess of 300 yards. Next is the flat nose. It's primarily used in hunting because it has more lead exposed at the nose of the bullet, which allows for rapid expansion. Another inherent advantage of flat-nosed bullets is that they provide safer feeding in rifles with tubular magazines. This avoids having the point of another bullet impacting the primer of the round in front of it under recoil. Round-nosed bullets have the same fundamental benefits and characteristics as flat-nose, but with an obvious ballistic coefficient improvement. Wad cutters are bullets with flat or nearly flat fronts and no ogive. Specifically designed for revolvers, wad cutters cut a very clean hole through paper targets, making it easier to score. While wad cutters are specifically designed for revolvers, semi-wad cutters allow for the same benefits in semi-auto pistols, but are shaped differently to feed reliably from a magazine. The final consideration when choosing a bullet is the heel. The most common form is the flat base. This is what's found on most commercially loaded ammo. The boat tail bullet, which has a tapered end, produces less drag and is preferred when shooting at distances in excess of 300 yards. Let's briefly discuss the firing sequence of a cartridge. We'll use a bottleneck cartridge in our example. When the firing pin strikes the primer, it crushes an internal anvil into the priming compound, which creates a small explosion. The flame from the explosion of the primer vents through the flash hole into the powder chamber and ignites the powder. The powder burns at a very high rate and creates gas and pressure, which pushes the bullet from the case and also expands the case to seal the chamber. The expansion of the case in the chamber prevents gas from escaping around the cartridge and out through the bolt. Since the case is held tight in the forward portion of the chamber, the case stretches just a little forward of the case head. The bullet pushes forward to engage the rifling, which consists of grooves cut in a spiral pattern all the way up the barrel. The lands are the raised portion of the interior surface of the barrel, and the grooves are the recessed surface. The forward movement of the bullet in the rifling causes the bullet to spin. The bullet continues to accelerate down the barrel and exits the muzzle with a high degree of spin imparted by the rifling. As we finish this section, I want to again emphasize that the concept of headspace is an important topic that every reloader should understand. A reloader changes the amount of cartridge headspace when he full-length sizes the case after firing. It is important to learn how to control the amount of sizing to provide enough cartridge headspace to allow easy chambering, but not so much sizing that excessive cartridge headspace is created. Excessive headspace between the loaded round and the chamber will result in too much stretching of the case and can lead to shortened case life or case failure. Let's talk about the basic tools and equipment we need to put the loaded cartridge together. First and foremost, you'll need a good reloading manual. This is an indispensable tool for any reloading bench. It provides an overview of the basic steps involved in reloading, as well as specific load data for each listed cartridge. Load data provides guidelines for loading a particular cartridge, as well as an indication of which powder and bullets to use to achieve the desired velocities, as well as all of the necessary dimensional data such as case trim length and cartridge overall length. These books go way beyond just being a recipe book. They are a necessity for safety. Now let's talk about the foundation of your loading bench, the reloading press. You'll commonly hear presses referred to as 7/8 by 14 presses. This simply refers to the diameter and thread pitch of the hole that the reloading dies thread into. Presses can be divided into two basic groups, single-stage presses and progressive presses. The one I have here in front of me is a Redding single-stage press called the Big Boss 2, and it performs one basic function with each pull of the handle. A progressive press performs multiple reloading operations with each pull of the handle. Progressive presses are favorites with high-volume reloaders, especially those that shoot thousands of handgun rounds per year. When you buy a reloading press, make sure it's sized properly for the cartridges you're going to be reloading. Make sure the throat opening is large enough and that the press has adequate leverage, especially if you're going to size large hunting cartridges. The next item on our list is reloading dies. For bottleneck cartridges, a set will consist of a full-length sizing die and a bullet seater. You can always add a neck sizing die if you want to just size the neck of the cartridge. The full-length die is used to size most of the body of the case, push the shoulder back to ensure the case will seat properly, decap the spent primer, and size the neck to the right inside dimension to properly grip the bullet. Almost all full-length sizing dies consist of a die body and a decapping assembly with an expander ball. The bullet seater is used to seat the bullet into the case to the desired overall length. Some bullet seaters also have a crimp ring inside the die that you can use to crimp the case neck to the bullet if you desire. A basic bullet seater consists of the body and an adjustable seater plug. Most dies are cartridge specific, but some bullet seaters will cover a small range of similar cartridges. Let's talk about the basic tools and equipment we need to put the loaded cartridge together. Pistol die sets usually consist of a sizing die, an expander die, and a bullet seater die. Many of the sizing dies in pistol cartridges feature a carbide sizing ring on the die that eliminates the need to lubricate cases. To use the dies, you'll need a shell holder that's the proper size for the cartridge you're loading. Most shell holders fit several different cartridges. They snap in and out of the press and are interchangeable with most brands of presses. A priming tool is not absolutely necessary if your reloading press has a priming arm, but it is a tool we recommend you have, as the priming is much easier and more accurate when performed in a separate operation. There are single feed tools like the Sinclair tool we have here, or automatically fed priming tools like the Lee Auto Prime or the Hornady hand priming tool. As we move to powder dispensing, it's important to know that powder is dispensed or thrown by volume, but reloading manuals provide charges by weight of powder in grains. So to dispense powder, you need a powder measure and a powder scale. The powder measure throws a charge by volume. You adjust and set up the volume that the powder measure throws by using a scale to check the weight of that volume. When buying a powder measure, check to make sure it has the capacity you need for the cartridges you're loading. You can choose either an electronic or balanced beam scale. Make sure you set them on a level surface and turn off any air vents near them, as they're very sensitive. You should check the calibration of your scale with check weights each time you use it. You'll need a case trimmer unless you're only planning on loading your cases one time. As your cases are fired each time, your brass will lengthen. Your reloading manual will have the published trim length and the maximum allowable length. You must not exceed the published maximum allowable case length, since it's very important to safety. If any of your cases become too long, you can actually crimp the case neck around the bullet when you feed it into the chamber. This situation will cause dangerously high pressures. The trimmer is used to trim all your cases back to the correct length and only needs to be done occasionally. This trimmer by L.E. Wilson and Sinclair is one of the most accurate trimmers on the market and uses a tapered shell holder for holding the case. This is my choice for rifle cartridge trimming, especially bottleneck cartridges. Some miscellaneous tools you'll need are case lube for lubing your cases before sizing, a dial or digital caliper, a hex key set, a powder funnel, a case mouth deburring tool for champering and deburring the case mouths after trimming, a neck brush for cleaning the inside of the case neck, a primer pocket cleaner or uniformer, and a loading block for holding your cases. Some additional tools that make loading a lot more enjoyable and easier are a tumbler for cleaning your fired cases. Let's go over the reloading steps for a bottleneck cartridge, in this case the 223 Remington, one of the most commonly reloaded cartridges. We're going to load some cases that were fired out of an AR-15. They've been tumbled for 30 minutes or so and separated from the media and appear fairly clean and ready to load. Using a tumbler is a fast and easy way of cleaning fired cases. If you don't have a tumbler, you can use some fine steel wool to clean the outside of the cases. It works fine, it just takes a bit more time. After tumbling the cases, I like to do a little extra cleaning of the case neck, which only takes a second or so with a case neck brush. While cleaning the case necks, inspect the cases for any signs of failure or wear to make sure they're in good shape. What you want to look for are really bad dents and signs of case head separation, which sometimes shows up as a distinct line on the body of the case down near the web. Also, look for split necks and torn rims from extraction. Next, wipe the cases off with a clean cloth and remove any compound left from the media. This gives you another chance to inspect the cases. Now we want to resize the case to the pre-fired condition using the full-length sizing die. The one we have here is from RCBS, and we're going to screw it into the press and then set it up to the right position according to the die manufacturer's instructions. The basic setting in most die instructions will let you size cases so they'll fit almost any gun chambered for that cartridge. First, we'll put a shell holder in the press and then thread in the die. We're going to leave the lock ring backed out until the die is set to the final position. Raise the ram to the fully extended position, then thread the die further into the press until it touches the top of the shell holder. Next, turn the lock ring down until it makes contact with the top of the press, and use the lock screw to lock the ring in place. This will prevent the ring from moving, so the die will be correctly set up every time we use it. Next, we'll position the decapping rod. You want to adjust it until the pin is protruding approximately 3/16 of an inch below the die body. This allows the pin to fully eject the spent primer. Once in place, make sure to lock the decapping rod in place with the lock nut on top of the die. When full-length sizing, you need to use a good lubricant to keep the case from getting stuck in the die. We'll use a product called Imperial Sizing Die Wax. Just put a light film around the case body. You don't want to use a whole lot of this since too much can cause dents to form on the case shoulder and body from the pressure generated in the die. If you're going to use a large number of cases, say 50 or more, a better choice would be to use a spray lube like Hornady One Shot. With the die adjusted in the case lube, we can put the case in the shell holder and run it up into the sizing die. This squeezes the body of the case down and pushes the shoulder back to pre-fired dimensions. At the same time, the decapping rod pushes out the spent primer so a new one can be seated later on. As we lift the handle to withdraw the case, the neck, which has been sized down a bit more than needed, passes over an expander ball mounted on the decapping rod that expands the neck to a couple thousandths under bullet diameter. By sizing the neck down first and then expanding it from the inside, we can ensure every case will have the same inner diameter and will have uniform neck tension when the bullets are seated, even if the neck walls are different thicknesses. This is important as neck tension has a great effect on consistency and accuracy, as well as the pressure generated in the chamber. Now that we have a few cases sized to the proper dimensions, we can use a Sinclair uniformer to clean the bottom of the primer pocket as well as cut the depth to the proper dimension. This is also a good time to check case length. If any of the cases are longer than allowed by the manual, they need to be shortened with a case trimmer. We'll cover setting up a Sinclair case trimmer and shortening the cases in another video. The cases we have here are all within spec, so we're ready to put our components together. The first step is to prime the cases. We're using a Sinclair priming tool. First, insert a primer into the tool, put the case in the shell holder and turn it to secure it in place. We want to be sure the primer is fully seated in the primer pocket and that the primer is flush or below flush with respect to the case head. This will prevent a slam fire caused by a primer protruding above the case head. Once we have all our cases primed, we can set up the powder measure. Our reloading manual lists 23 grains of Vitavori N135 powder behind a Nosler 55 grain ballistic tip as an accurate load. The book says this loads well below maximum, but we'll still need to watch for high pressure signs when we go to the range. The Redding powder measure we're using has been set up for the correct charge, but first we're going to cycle about 10 throws through the measure and then place the powder back in the reservoir. This procedure removes compressed powder that resulted when we first filled the reservoir. We'll then refill it and try to keep it always filled about a third of the way up or more. This helps avoid light compression in the powder drum and results in more consistent charges. Next, we'll throw a charge into our scale pan and check it against the desired 23 grains. Our scale tells us we're right on the money, so we're good to go. By the way, when you're using a powder measure, be sure to fully cycle the handle in both directions to avoid light charges and ensure consistency. You can either charge an entire block full of cases or charge an individual case just before seating the bullet. Be sure to give your cases a good visual scan to be sure they all have powder charges. This is very important. You don't want a case with either a partial charge or no charge. That's a good way to get a bullet stuck in your barrel, a very dangerous and potentially lethal situation. Now that all our cases are charged, let's seat the bullets. The bullet seating die has an adjustable stem that you move up and down within the die to achieve a different loading depth. We're going to seat the bullets so the overall length of the cartridge from base to tip is equal to what's recommended in the reloading manual. To set up the bullet seater, we first thread into the die till it bumps the shell holder in the fully raised position. In this demonstration, we've decided to disengage the crimping feature. To do this, we just need to turn the seating die one full turn back off the shell holder. Then, as with the sizing die, we can turn the die body lock ring down into place. If we were going to use the crimping feature, we'd turn the seater back toward the shell holder until we reach the desired amount of crimp. The decision to crimp bullets is partially dependent on the bullet design and whether you're concerned about bullet movement in the case neck while it's under recoil in the magazine or during feeding. In most situations, the tension of the case provides enough bullet grip to securely hold the bullet in place. However, if you're loading for a hunt or tactical competition, you probably should utilize a crimp to ensure reliability. Now that the die is in place, let's set the seating depth. Back the seater plug out sufficiently so that when a charged case with a bullet is raised into the die, the bullet doesn't contact the seating stem. With the case raised fully in the die, turn the seating stem until it just contacts the bullet. You'll feel it touch. Back the case out of the die and turn the bullet stem a quarter of a turn or so and raise the case back in the die. This should result in the bullet being partially seated. Now begin a trial and error process of turning the seating stem into the die until you reach the overall cartridge length. When you get to the correct overall length, lock the seater stem in place with the lock nut. After loading the rounds, you should place them in a cartridge box and use a load label to identify the components used, including the type of brass, the bullet type and weight, the primer, the powder charge, and the date loaded. Some simple record keeping now can save you time and effort down the road, especially if you find a combination that really works well and you want to duplicate that load. If you're a competition or precision shooter, you should also record this information in a reloading log for the particular firearm you're loading for. This documentation will also let you keep track of the rounds fired through your gun and how different loads perform. In this segment, we're going to reload the 9mm Luger. We have a batch of clean brass ready to reload. Be sure to inspect them carefully for damage, wear, or signs of failure such as split case mouths, cracks on the side of the case, or abnormal bulging. Be sure to eliminate these cases along with any others unfit for reloading like aluminum cases. First, we'll size our cases in a full-length sizing die. We'll use a single-stage press so we can see each step separately. Pistol dies are available in carbide or steel. The advantages of the carbide die is that you don't have to lube the case or remove lube from the case afterwards. When setting up a carbide sizing die, run the die down till it just contacts the top of the shell holder when the press ram is in the fully extended position. Once you have the die touching the shell holder, secure the die lock ring. When using a carbide die, it's best to put only very light pressure on the bottom of the die with the shell holder, because heavy pressure can crack the carbide portion of the die. After securing the lock ring, adjust the decapping rod assembly so the decapping pin is protruding from the bottom of the die approximately 3/16 of an inch. Then lock the decapping rod in place. Okay, let's resize some cases. Next, we'll check case length using calipers. The maximum allowable length for a 9mm Luger is .754 inches. If any of the cases reach or exceed the maximum allowable length, then you need to trim the entire batch of cases. If you need to trim, make sure you deburr the case mouth inside and out. None of this batch exceeds the maximum case length, so we'll move on. The next step is to clean the primer pockets using a primer pocket uniformer or primer pocket brush. Next, we'll expand the cases in the expander die, which opens the case mouth to accept the bullet. A portion of the expander rod in the die has a belling or flaring shoulder. The purpose of the belling shoulder is to slightly flare the mouth of the case to more easily accept the bullet. Thread the expander die into the press until it contacts the shell holder in the raised position. Then back the expander rod out so the expander rod is just entering the case mouth. Then slowly turn the expander rod down until the belling shoulder begins to contact the case mouth. Make very small adjustments until you have just a small amount of bell or flare on the case mouth. When using flat-based bullets, especially cast bullets, belling or flaring the case mouth prevents the soft lead from shaving as the bullet is seated. Next, we'll prime the cases using a Lee Auto Prime tool. We'll go ahead and prime the entire batch in one sitting. As the cases are primed, check to make sure that each primer is flush or below flush with the case head. Then put the cases head up in the loading block so you can visually check the entire batch when finished. Next is charging the case. Verify the amount from the reloading handbook, double check the powder bottle, and verify the thrown weight of the powder charge with a scale. Let's throw a few rounds. Now we're ready to seat bullets using the bullet seater. We'll seat the bullet in this step and perform the crimping function in another die. Since this is a 9mm Luger that headspace is on the case mouth, it requires a taper crimp. Install the seater so it's backed away from the shell holder a full turn so the standard crimping feature will not engage. The seater is set up to achieve the overall cartridge length from the reloading manual. Check the overall length of the completed cartridge using your dial calipers against the published overall length in your reloading handbook. Turn the bullet seating stem in your die to adjust the length. The finished length may differ slightly from the published length by a few thousandths, no more than plus or minus 5 thousandths because of bullet shape. Let's go ahead and seat all the bullets. Now we'll run the loaded round up into the taper crimp die to complete the crimping operation. As the loaded round is removed from the shell holder, check each round to make sure the crimp was formed properly. Transfer the newly loaded ammo to a proper cartridge box and record information on the label provided with the box. Lastly, we'll cover a few common questions new reloaders typically ask. How many loads can I get out of 1 pound of powder? Let's use the .223 Remington we loaded earlier in this series as an example. We used 23 grains of Vitavori N135. There are 7,000 grains in a 1 pound canister of powder. If we divide 23 into 7,000, we get approximately 304 loads. That would equate to over 2,400 rounds for an 8 pound container. How many times can I reload a fired case? That's not as easy a question. A lot depends on the geometry of the case, the alloy of the metal used in the case, how much sizing is done, and how hot of a powder charge is used. The reloading industry has typically recommended destroying the brass just before it needs trimming for the 5th time. So after 4 trimmings, you should be watching the cases and getting rid of them before they need trimming again. What's the shelf life of reloading powder? There is no set shelf life for smokeless powder. We recommend keeping your powder stored in a cool, dry environment. Also, remember to keep your primers and powders stored separately. This concludes our introductory reloading series.